Hello friends, welcome to my YouTube channel Concept Clear. In today's class, we will discuss about AES algorithm, Advanced Encryption Standard Algorithm. Okay, if you see, in last class, we discussed about DES algorithm. What is DES algorithm? Data Encryption Standard Algorithm. Okay, it is replacement of, AES is the replacement of DES algorithm. Okay, see here. It is a symmetric key block cipher. What is the meaning of symmetric key? First of all, a symmetric key is nothing but here a single key used for encryption as well as decryption. Okay, the same key used for encryption as well as decryption, those are called symmetric key. Okay, and what about block cipher? The plain text data is divided into number of blocks, and as well as the same number of the same size of the bits will be created as the cipher text, that is called block cipher. Okay, next, AES algorithm was established in the year of 2001 by National Institute of Standard and Technology, and it is a AES algorithm contains totally 128 size. It contains fixed block size. The size is 128 bits, and it will take totally 10 rounds of round operations. It will perform totally 10 rounds of the round operation. And what about DES? In DES we are performing 16 rounds. Here we are performing 10 rounds. And AES is the replacement of DES algorithm. AES is the replacement of the DES algorithm. And in AES, key size will be changed based on the plain text, and the number of the rounds are also depends on the key size. Okay, in DES algorithm, it is the size is 64 bits, key size also 64 bits. In that, we will convert 56 bits as a subkeys. Again, in the 56 also we will use the 48 bits for the round operation. But in AES algorithm, the plain text size is 128 bits, and the key size will be depends on your requirement, and the number of rounds will be depends on the key size. Suppose if you take 128 bits key size, then the rounds are 10, and suppose the rounds are 10. Suppose if you take 192 bits, the rounds are 12. Suppose if you take the 256 bits, the key size means that totally it will perform 14 rounds operation. Okay, clear? Next, here the plain text represents 4 into 4 column measure matrix. The main thing is in AES algorithm, the AES algorithm represents in the form of the 4 into 4 matrix. 4 into 4 matrix. Here the key size is 128 bits, which is passed in terms of the words. Generally, the 128 bits will called as the words. The form is words. Okay, here. The key size is 128 bits will be passed in terms of the words. It will be 128 bits will be considered as in the form of the words. Here, what is the word? Here, one word equals to 32 bits. One word equals to 32 bits. It means if we are taking the key size is 128 bits, then how many words? The 128 bits will be converted as 4 words or 16 bytes. 4 words are 16 bytes. The number of subkeys are equals to 44. We used in each subkey size is 32. 32 bits or 1 word or 4 bytes. The total number of subkeys we are using means 44. Okay, we are using these are the round operation. Next, see, in each round we are using 4 subkeys. Those are the 4 into 32. Those are the 4 into 32. That means what? 4 into 32 means 128 bits. Okay, to perform in single round operation, we have to use the 4 words or 16 bytes. 4 words are 16 bytes. Okay, see here, this is the AES algorithm block diagram. This is the AES algorithm of the block diagram. In this one, I will explain clearly. Don't confuse here. Here, left side, we will take plain text message. Right side, we will take the key size. Right side, we will take the key size. Okay. Here, first step, in 128 bits plain text message will be converted into 4 into 4 matrix. I already explained that where the plain text will be converted into 4 into 4 matrix state format, that is the input, and after that the 4 into 4 matrix will be applied to initial transformation. What is the meaning of initial transformation? So already seen in DS algorithm. Here initial transformation means simply the changes of the bits position. Simply bits positions will be changed. That is called initial transformations. Next, and after the output of the initial transformation, this is the again we will get the 4 into 4 matrix. Okay, here to perform initial transformation, we will get round key 0, from where? From key. Okay, see here, from right side we are taking the key, and the key is also converted into 4 into 4 state format, and then output will be went to the key expansion. Okay, here there is a block, key expansion block. Okay, here key expansion block means it will generate the sub keys. The key expansion block will be generates the sub keys for each round operation. Here at the time of the initial transformations, the key generator, the key expansion will be generates round key 0. The round key 0 used for is the round key 0. It is also 4 into 4, and by using this round key 0 operation, the initial transformation will be performed with plain text, and the result of this one again into 4 into 4, that will goes to round 1 operation, that will apply to the round 1 operation. And at the time of round 1 operation, again this key expansion will generate a key 1, that is also that will be implemented, that will be applied to the round 1 operation with help of the key and previous output data. Both will be performed round 1 operation. After round 1 operation, the result will be goes to the round 2 operation. Again the key expansion will be generated the second key 2. With help of the key 2, we will perform the round 2 operation, and up to like this, totally based on the key size, several rounds of operation will be performed. At end of the last round, we will get cipher text. At the end of the last round, we will get cipher text. Okay, these are about the AES algorithm. Here the main important is in round 1 and round n minus 1, we will perform 4 transformations. Okay, in each round we will perform 4 transformations. In round 1 to up to n minus 1, means last before round, we will perform 4 transformations. And what about in round n? It means in the last round we will perform only 3 transformations. Okay, what is the operations will be happening in the rounds? We will see in this video only. Okay, this is about the DES algorithm. Okay, see here, and what are the transformations we are performing? Okay, see, these are the in round operations. What is the round operation will be happen inside the round operations? Okay, round operations. In round operations, we will perform 4 transformations. What are the 4 transformations we are performing? Here, the first transformation is substitute the keys. Second one is shift to rows. Third one is add row matrix, and fourth one is the add column matrix. These are the 4 transformations we will perform in round operations. But the first one will be performed if you take 128 plain text means, and the key size also, we are performing 10 rounds, and second one also performed 10 rounds, and third one will perform only 9 rounds, and last one also perform 10 rounds. It means first one, second operation, and fourth operation will be performed each and every round, and in the last round, the third one will be not performed. Okay, what is the substitute bytes? Okay, what is the first transformation? Substitute byte. Here, where the one byte is replaced with another byte. Okay, for example, see here, this is the 4 into 4 matrix. Okay, assume this is the 4 into 4. Here, this is the bit. Okay, assume here we are writing S00, S01, S02, S00. Okay, like that we are taking here. If what is meaning of substitute of the bytes means one byte replaced with another byte. Okay, here suppose here the data is 45. Assume here the data is 35. Then if you are performing substitute bits, the 35 will be replaced with some other bit. For example, like 45 or some random number will be updated instead of 35. That is called substitute of the bits. Okay. Substitute of the bits in round 1 we are performing 4 transformations. For convention we use predefined S boxes. Here for example if the data is 35, after substitution we will get the 45. After substitution we will get the 45. Okay, the second transformation is shift to row transformation. What is the meaning of shift to row transformation? Shift to row transformation is nothing but one position of the row will be shifted to left side. One row position will be shifted to left side. For example, shift to row operation we apply after substituted matrix. Simply shift to row of the table. Row 0 to no change. Here row 0 is no change. For example, it is the basic. It is the initial data. It is the shifted row. Okay, here shift to row. Yes, there is a row 0 is no change. So it is the as is. And what about here? In row 1, the first data is row 10, and what about here row 11? Okay, after shifting this one, okay, that means the left side first all the row first cells will be shifted to left side. Means this is the left side means what happened? It again will come to the right side of this one. Okay, same here also. S10 is shifted means it goes to right side one, and here also S20 also. Here in first row we are shifting one circular shift, here two circular shifts, here three circular shifts. Okay, here 10 is shifting means what? Circular means again that we have to move to right side, and here two circular shifts. So S20 S21 is shifted to right side. So S222 came first one, S223, and here S220 S221. Okay, here three circular shifts means the first three cells will be shifted. So S33 is coming first side and remaining 30, 31, 32. Okay, this is about the shift to row operation. This is the second transformation. And what about the third? Okay, what about the third transformations? In third transformation is nothing but add column matrix. Here each and every column is treated as the separately. Okay, don't confuse here. In this one, each and every column will be treated as the separately. That is, we are performing operations on each column identically. Okay, it means in each and every column we have to perform the operations separately. Okay, for example, here taking matrix values. For these are the random values I am considering. These are the matrix values, random values. Okay, only three values. Okay, if it is the first row, there is no change. Okay, in first one there is no change. And what about the byte? In the second time, the bytes will be replaced with corresponding values. Okay, here first one is the no change, and what about the second value will be changes according to corresponding values. If the byte is multiplied with 1, then the column position will be not changed. Okay, here the entire the matrix, if you multiply with 1, there is no change. There is a no change. And if the byte is multiplied with 2, if this data is multiplied with 2, the column position will be shifted left side one value. The entire, if you take the first column is no change. Okay, if you multiply with 2, one value will be shifted to left circular operation. Again means this will be come to the this side. And if the shifted by 2, if multiplied with 2, that means the column positions will be shifted left side by 1. Okay, and if we multiplied with 2, 3, the column position will be shifted left side 1 and perform XOR operation with left shifted column and before shift key, after shift key for performing XOR operation. Okay, this is called add column matrix. This is about the add column matrix. And fourth transformation is add round key. What is the meaning of add round key? At each and every round, we have to add round key value. That means from key expansion, we will get a key that will be added at the plain text. Okay, in the main. Okay, see here, this is the plain text message. Here we are getting the key. These both will be perform XOR operation. And what is the data we are getting? That is the add round key output. Okay, text and key you are performing XOR operation, and after that we are getting the add rounded key plain text message. This key with applied to each and every round. Okay, here the main thing is in round operations we will perform 4 operations. The first one is substitute bytes, second one is the shift rows, then third one is the add row matrix, fourth one is the add column matrix. Here first one and first two, we have to apply 1 to n minus 1 rounds are, we have to apply 4 transformations. Okay, and what about the last transformation? In last one we will apply only substitute bytes, substitute rows, add row matrix key only. Okay, here what is the key expansion? Key expansion is nothing but how the sub key are generated in round operation. How the sub key are generated in round operation. Okay, these are very important. Okay, here key size is 128 bits. Key also represents state format. Key also represents in the state format. Okay, here, okay, assume here this is the key. This is the main important diagram. Here the key is the divided into K16, 4 into 4 matrix is the key. Now how it will be the keys will be generated. Here in the entire column we are writing W1, W2, W3, W4, and after that if you want to expand more number of keys, okay, here we have to perform XOR operation. Here we have to perform W1 with, we have to take a special variable Z1. We have to take a special variable Z1. After Z1, with Z1, if you are perform a special, if you perform XOR operation, we will get the W5. Okay, we will get the W5. W5 means what? It is a some additional next key. And to get the next key, I have to perform W2 with XOR with W5. We have to take W2 and XOR operation with W5. Then we will generate the W6. And again, if you want to generate W7, you have to take W6 XOR operation with W3. Then we will generate the W7. To generate W8, we have to take W4 XOR operation with W7. We will generate the W8. Again, if you want to generate W9, again we have to perform W9 XOR operation with W5. Will generate the, again we have to take one more variable, we have to take W9, we will get the W9. Again if you want to generate XOR operation with W9, will generate the W10. Okay, like this. W11 if you want to generate, W11 means XOR operation with W10 with W7. Okay, then we will generate the W11. Okay, like this procedure will be continuous up to how many number of keys you want. Okay, to say simply the block diagram of AES is, this is the simply block diagram. Here the plain text will apply the round key operation. Inside the round we are perform the 4 transformations. These 4 will be performed in up to n-1, and the last round will apply only these 3 operations. In last round will apply only these 3 round operations. Okay, clear? This is about the AES algorithm. If you have any doubts, please ask me in comment section. Also share our videos with your friends. Okay, thank you. Okay, thank you everyone. Please subscribe my YouTube channel.
నా ఛానల్ పేరు గుర్తుందిగా, ప్లీజ్ లైక్, షేర్ అండ్ సబ్స్క్రైబ్.